Hello, this is the demo that I'm going to show you by using red cabbage leaves as a pH indicator. Now, what is pH? pH is power of hydrogen. It's usually hydrogen ions that is measured, but in common lingo, we just say this is something that can help us detect what is an acid and what is a base. So I'm going to test the household chemicals that I have over here using red cabbage juice. To prepare red cabbage juice, take a few leaves off the red cabbage. This is just the red cabbage I bought from the grocery store. Took a little bit out of this and chopped it and then boiled it, strained it, cooled that liquid, and that liquid is the red cabbage juice that I have here. So it is the deep blue color that you see, okay, in this container. And now I'm going to test this red cabbage juice with several different household chemicals and see what is the color change that we get. To start with, I'm going to test it with vinegar. Now, vinegar is acidic. Vinegar is acetic acid. The chemical name for that is acetic acid. And I'm going to pour a little bit of this vinegar, it's just white distilled vinegar, into the container and see if we see any change. Okay, so here's the juice, the red cabbage juice, and I'm pouring it. Did you see any change? Yes, you did. So this is the deep blue color changing into deep magenta pink color that you see over here. Whenever the red cabbage juice changes to reddish or pinkish shades, that shows that the chemical that we have poured in is an acid. Let's try it with other household chemicals. So now I'm taking a fresh sample of the same red cabbage juice, and I'm going to test it with orange juice. Any orange juice will do. It is better to use something that is not made from concentrate to show the change better. Okay, so let's pour this in and see what type of change we see here. All right, now you can see this gave us the change as well. And this is more of a faint pink color.
Hello, my name is Jonathan Paradise. Why did we see a layering effect?
The reason for that is orange juice has a higher density, slightly higher density than the red cabbage juice. The red cabbage juice is more like water's density. This is thicker. So when I poured it in, it kind of settles at the bottom. You saw it again. It settled at the bottom. And therefore, the change is more evident at the bottom than at the top. It takes me a mix or two to get the whole color consistent and change. You can see now that it is a fainter pink.
Okay. My name is Broker. What will happen if you keep adding orange juice?
Well, you will see that it does keep on changing into a lighter and lighter color. So now you can see it's more orangish or yellowish. And those are the transitions that we see for red cabbage juice. It starts from the deep pink or red, and then as you add acid, lesser and lesser concentration of acid, items that are not as acidic, you will see the change being more of faint pink to light orange to yellowish. Let's test some more household chemicals and see if we see any change. The next one I have here is isopropyl alcohol. Now, isopropyl alcohol is flammable. I want everyone to know that this is not something we let the younger kids work on themselves. You can also recognize I'm wearing gloves to protect myself. And being that this is a fire hazard as well, this needs to be disposed of correctly. This needs to be used correctly according to the instructions given on the container. But for our demo, here is the fresh sample of red cabbage juice again. And let's see if we see any change if we put in isopropyl alcohol. So I put in almost the same amount as I put for vinegar. And do you see any change? Is there any change? No, there's no change. Let's try a little bit more. Let's see if there is, maybe it needs a little bit more. Still no change. So what does this tell us? This tells us that isopropyl alcohol is neither acidic nor basic. It is neutral. So it's not showing any change for our red cabbage juice. Next item that we are going to test is a solid. So it will take some time for it to dissolve into our red cabbage juice. So this is a fresh sample of red cabbage juice again. I'm placing it here, and I'm going to test it with baking soda. Now, I put in about a couple of spoons, but it's a good idea to try it by putting it little by little and seeing if there is any change. It just makes it interesting to see how this change occurs if you put a little bit of chemical rather than put in a lot at one time. So I have put in about a spoon of baking soda on the top, you can see it on the bottom, and now I'm going to mix it. Okay, and I want you to see if you recognize any change. Again, this is a slower reaction. This is where we need to give it some time to react because it's going to dissolve and then react. Okay, so what has this done? It is not that deep blue color anymore. It is a faint green blue color, turquoise color. Let me put in a little bit more and show you the change and compare it to a fresh sample of red cabbage juice. So I put in one more spoonful of baking soda and I'm mixing it again and letting it react. Okay, and now you can see it has taken away its blue color for most of the sample. It is a fainter blue or a greenish blue color. And this is the original color of the red cabbage juice. So now you can see that there is a difference. It is not drastic, but the reason this is giving us a fainter color or a greenish shade to this sample is because it is a base. When you have a basic sample, then that is going to change the red cabbage juice to a greener shade. The next one that we are going to test is ammonia. Now, ammonia can be found in our grocery store. It is a cleaning agent, but it is extremely corrosive and it is an irritant. I highly recommend doing this for the younger kids or wearing a mask and goggles because it's an eye irritant as well. Now, a dilute form of this is also available as our glass cleaner. But the reason I'm not using the glass cleaner is because it already has that blue shade as a background. So I bought this ammonia from the grocery store, which is giving me this clear liquid. It's originally a clear liquid. And I'm going to pour this into the red cabbage juice and see what happens, okay? So I poured it slowly. Did you see any change? Do you see any change now? Okay. Did you see that it has turned into a green liquid? Into a green liquid. Now at this time, I'm going to show you this in a smaller container because it's going to be more evident if I show you in a smaller container. Do you see that it is now green? Yes, it is. It's a deep green color. And that is telling us that ammonia is highly basic.
Hi, my name is Joseph Sweeney. Yeah, I have a question. What will happen if you add acid to the sample? Will the color change back?
Well, let's try it. So in the sample, which is the red cabbage juice with ammonia, I'm going to put little by little the vinegar. That was our most acidic of the sample. So that's the vinegar. So I'm pouring it slowly and you tell me if there's a change. Is there a change? Did you recognize a change to blue? Do you see it's more bluish now, not greenish? Okay, let's keep on going. Let's add some more. What happened? It is now purplish. Do you see it is changing into purple? Okay, let's add some more and see if you see any change. I'm adding more to it, and now it is giving me that pink color again. This is the pink color from the vinegar and the red cabbage juice. So yes, red cabbage juice has the capability to give you different color indicators when there are other chemicals placed in it. Being it an acidic or basic system, it gives you reddish for the acidic system, greenish for the highly basic system, and different colors in between when you have neutral or lighter acidic or basic.